In this video, we will show you how you can use the Unicorn BCI Recorder and a Unicorn BCI Core with 8 channels to record EEG and run a Visual P300 Oddball Paradigm. The event-related potentials we will then visualize in real time using gHIsys. First of all, we need to start the Unicorn BCI Core Recorder, and assuming your hardware, meaning the Unicorn BCI Core, is active, then you should be finding it here. In this case, there are 2 BCI Core available, but the one that I am using right now is the U8 2024-1111. Therefore, we are selecting it and click on Connect. And there we go. We are connected, and if I click on the cog here, which leads me to the settings, you can see in Acquisition that I am not only recording the EEG but also some additional channels such as the battery level. This leads to 13 channels in total, as you can see down here. Then, in the Recording tab, it says which files we want to record and save. Generally, there is both CSV files and BDF files that either record the data raw, meaning unprocessed, or with the filters enabled. In the Network tab, we can configure a UDP interface, which we will be using to receive the trigger information, or in other words, cue information, when we run the paradigm. And additionally, there is also a lab streaming layer, which we will use to stream the data from the Unicorn BCI Core recorder to gHIsys. As I am in Europe, we will be using a 50 Hz cascading notch filter to remove the power line noise. And additionally, we are using a 0.5 to 30 Hz bandpass filter at the moment. And now we can click on play in order to acquire the EEG data. After the filters have settled, I can, for example, close my eyes, which results in some nice alpha waves. Or I can blink with my eyes, causing big EOG artifacts, especially on the first channel. And finally, I can also clench my teeth, causing some high-frequency artifacts. So as you can see, the EEG looks good, which now brings us to a gHIsys example model in Simulink. In here, we will be receiving the data via the lab streaming layer, or in short, LSL. And of course, this LSL stream name must correspond with the one from configured in the Unicorn BCI Recorder. We record with 250 Hz and expect 13 channels. From these 13 channels, we are extracting the EEG channels for some visualization. And down here, we are extracting the trigger channel, which tells us what stimulus I am currently looking at. In this block, we are extracting the event-related potentials and perform the epoching and averaging of the event-related potentials, which are then finally visualized by the EP scope. Going back to the Unicorn BCI Recorder, we could either record and save the data by clicking on the circle icon, or we can simply acquire it without saving. No matter which option I choose, the data will be transmitted via the LSL. But as this is just a demo, I will be going for simple acquisition without saving. So I click on play to start the acquisition in the Unicorn BCI Recorder, and then we switch to our Simulink model. Here in Simulink, we will click on Run, and we are now receiving the data also here via the LSL receiver. I can again close my eyes, resulting in alpha waves. Finally, here in the EP scope, we are expecting the evoked potentials for each of the 8 channels to be shown later on when I running the paradigm. Using the paradigm remote control, which comes with gHIsys. By launching it, a remote control bar appears which you can drag anywhere you want. Here we will be loading the Visual P300 Paradigm, which will also send the UDP trigger information to the Unicorn BCI Core recorder. Additionally, we are opening a new subject window where the visual stimuli will then be presented. Also, this subject window you can drag anywhere you want, and by double-clicking on it, it becomes full screen. In our case, we will be dragging it to the bottom left corner of my screen, as we will also visualize the EEG data and open the EP scope. Now that all the windows are positioned, we can click on Start Paradigm and get going. 8 different images will be shown, with the colorful image being the target, or in other words, the oddball. In the EP scope, you will see 2 different event-related potentials. The red one will the average non-target event-related potential, and the blue one is the target event-related potential. Channel 1 and 3 are the FZ and CZ electrode, which nicely show the P300 responds. Additionally, you will see for channel 7, which is over the visual cortex, that there is a positive peak every 100 milliseconds, which happens because every 100 milliseconds a new image is shown. This was our video about the Unicorn BCI Core recorder interfacing with gHIsys via lab streaming layer Visual P300 experiment. Thanks for watching.